Good morning. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatul, Kathmandu and Kumudini Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in your science class we have been studying about lesson light. And up to our previous class we learned all about reflection. Yes, we learned about reflection, laws of reflection, okay, and then the ray diagram of image formed by concave mirror and image formed by convex mirror. We even discussed why a concave mirror is called converging mirror and convex mirror is called diverging mirror. Okay, in today's class we are going to discuss something bit different. Okay, something different from reflection. See here, look at this picture. A glass of water is shown. What do you see in this picture? Just this one. It shows a glass of water, but did you see something unusual? You all have seen glass of water, yes? Nothing is new over here. But if you see carefully, there is something particular, something peculiar about this picture. Okay? See here, if you haven't noticed it, what does the background scenario look like through the glass of water, through water? What does it look like if you see through the water? See, is it different or same? Yes, it is different, isn't it? It is different. Yes. Now we can see that whatever is behind this glass of water, you can see through water, but you will see a distorted image. You will not see actual image. You will see a distorted image, and the real image, a real object, you actually cannot see through here. यो ग्लास अफ वाटरबाट हेर्दाखेरि यो पानीको पछाडि जे छ त्यो कुरा तिमीले एक्ज्याक्टली कहिले पनि देख्दैनौ. You will not see anything exact. Okay, you will see distorted image. You will see distorted image, and in that process the real object cannot be seen through the glass of water. यो ग्लास अफ वाटर को थ्रुबाट रियल अब्जेक्ट देखिदैन, खाली यो डिस्टोर्टेड इमेज मात्रै देखिन्छ. किन यस्तो भयो त? यो ग्लास अफ वाटरलाई यहाँबाट हटायो भने अब यसको रियल अब्जेक्ट देखिन्छ नि, हैन? यो किन भयो त? आखिर पानी भनेको त ट्रान्सप्यारेन्ट अब्जेक्ट हो. Water is transparent material. That means you must have been able to see through it. Definitely you are able to see through it. But what you see? You will see distorted vision. You will have distorted vision. What causes it? Okay, this is my first concern. And next one, okay, you might have done this at your home. Okay, you might have done this several times. Like when I was children, I have done this several times, so I expect that you have also done so. Okay, what is seen here is a pencil is dipped in water, and when a pencil is dipped in water, actually we see it bend at the surface of water. We see the pencil is bent at the surface of water, and you look through. If you look through the side of water, then the pencil seems to be swollen. अनि यो हेर्दाखेरि मलाई त यस्तै लाग्थ्यो कि पानी मुनि राख्दाखेरि, पानी भित्र राख्दाखेरि चाहिँ पेन्सिल फुल्दो रहेछ, अनि अरू अब्जेक्ट ट्राई गरे सबै कुरा फुल्दो रहेछ पानी भित्र राख्दाखेरि, अनि पानी बाहिर निकाल्दाखेरि फेरि जसाको तसै हुन्छ, हैन? अनि मैले त के कन्क्लुजन निकाले भने पानी मुनि राख्दाखेरि पानीले गर्दा चाहिँ जे पनि कुरा फुल्छ भनेर मैले कन्क्लुजन निकाले. अब त्यो कतिको राइट हो रङ हो थाहा छैन, तर मैले चाहिँ त्यो कन्क्लुजन निकाले है. तर रियालिटी के भएको हो त? जस्ट द भिजन इज डिस्टोर्टेड. यहाँ पनि तिम्रो भिजन डिस्टोर्टेड भयो कि? डिस्टोर्टेड भनेको बिग्रियो है. यु आर नट सीइङ द रियल भिजन अफ द पेन्सिल. यु आर नट सीइङ द रियल भिजन अफ द pencil. You are seeing distorted vision of pencil. हैन? र अर्को यो एक्जाम्पल हेर त. This is an example of pond. Okay, and when you look down the pond, when you look down the water, what you see is the pond appears to be shallower. Okay, shallower means less deep. The pond appears to be shallower. You can see the rocks or the stones on the bottom of the pond. You can see them, and it looks like if you bend a little bit, you can get these stones, you can catch these stones. It looks like so. Okay, but if you get down the water, actually if you get down the water, you might drown in it. Okay, you might drown, or your leg might not touch the ground even. Just forget about picking up the stones, isn't it? Has it ever occurred or not? Especially if you have gone to swimming pool, and swimming pool, just by looking into water, it looks like the swimming pool, the water is not deep. It looks like the water is just of 4 feet, isn't it? So thinking that you will not get drowned in it because your height is 5 feet, thinking that you will not drown in it, you will jump in it, yeah, or you will go down the water. But you will be surprised to see that, to find out that your legs do not touch the ground, your feet do not touch the ground. And when you actually see for the sign, you will be surprised to read it to be 6 feet. That means the actual depth of pond or actual depth of the swimming pool is 6 feet, but it looks like 4 feet. It looks like 4 feet. So in case of ponds also, same thing. Yes, it looks like less deeper, looks like it is not deep at all. Okay, but if you get down there, you'll find it to be deep. Yes, so here also, in this case also, you got a distorted vision. Distorted vision means you are not seeing the exact thing. You are not seeing the exact thing. You are getting distorted vision. Your vision is distorted. And what causes distorted vision is the bending of light ray. See, this is the actual cause of all these features. Okay, we have discussed several features today, isn't it? At least 3 features. Yes, we have discussed 3 features about distorted vision. And what causes distortion of vision is bending of light rays. Okay, in grade 7 you studied that. You studied about rectilinear propagation of light, and rectilinear propagation means light travels only in straight line. Okay, light travels only in straight line. But you see, when light passes through glass or water or some other things, some other transparent things, then it happens that light rays bend. They do not travel in straight line, but they bend. Okay, in this case you can see this is a light ray, but instead of going to straight line, it bends. Yes, it bends like this, and after passing through glass, while coming out also, it bends. Okay, so this is the main thing. Okay, this is the main cause or main reason behind all of these distortions. Yes, now what is this phenomenon called? This phenomenon in which light ray bends when it passes from one medium to another medium is known as refraction of light. Okay, see, when light travels from one transparent medium to another transparent medium, it bends from its usual straight line path, and this phenomenon is called refraction of light. Do you get it? Okay, now let's discuss the cause of refraction of light. Okay, now the refraction of light occurs that mainly because velocity of light differs in different medium. Light does not travel with same velocity in all medium. Okay, its velocity is highest in vacuum and almost same in air, that is 3 into 10 to the power 8 meter per second. But when it travels in glass, its speed becomes 2 into 10 to the power 8 meter per second, and in water it travels at the speed of 2.27 into 10 to the power 8 meter per second. So because of this change in velocity of light, the bending occurs. Okay, like you can think about shooting a dart, isn't it? If your dart if you threw a dart and the dart keeps on moving with same velocity, then know that it will move it will move in a straight line. Okay, तिमीले एउटा बल फाल्यौ है, यहाँ चाहिँ डार्ट फाल्यौ. ओके, डार्ट या बल जे भन तिमीले फाल्यौ र त्यो फालेको बल यदि एउटै भेलोसिटीमा मुभ गरिराख्यो भने त्यो बल सधैँ के हुन्छ त स्ट्रेट लाइनमा ट्राभल गर्छ. ओके, तर तिमीले फालेको बलको भेलोसिटी घट्दै जान्छ नि हैन, घट्दै जाँदाखेरि त्यसको मुभमेन्ट कहाँ पुग्यो, त्यसको मुभमेन्ट चाहिँ के हुन्छ त ओके यस्तो तलतिर आउँछ, तलतिर स्लोपिङ हुन्छ मुभमेन्ट है. भेलोसिटी घट्दै गयो भने मुभमेन्ट तलतिर स्लोप हुन्छ, जबकि यदि भेलोसिटी बढ्दै गयो भने चाहिँ के हुन्छ त त्यसको मुभमेन्ट यसरी माथितिर स्लोप हुन्छ. ओके, यो कुरा बुझिराख. जब तिमीले कुनै अब्जेक्ट एयरमा फाल्छौ यदि त्यसको भेलोसिटी घट्दै गयो भने तलतिर स्लोपिङ हुन्छ भने बढ्दै गयो भने माथितिर स्लोपिङ हुन्छ. बाटो त चेन्ज हुँदो रहेछ नि भेलोसिटी चेन्ज हुँदाखेरि हैन. लाइटको केसमा पनि त्यस्तै हो, सेम भेलोसिटीमा मुभिङ छ भने मात्रै स्ट्रेट लाइनमा मुभ हुन्छ है. तर यदि यो चाहिँ डिफ्रेन्ट भेलोसिटीमा पास भइरहेको छ ओके भने यो केसमा हेर त, यदि यसको भेलोसिटी सेम भएको भए यसको बाटो यस्तो हुन्थ्यो होला, भेलोसिटी चेन्ज नहुने भएको भए लाइट यसरी सिधा जान्थ्यो होला हैन, यसरी सिधा जान्थ्यो. तर यदि चाहिँ मिडियम 1 मा भन्दा मिडियम 2 मा यसको भेलोसिटी बढी भयो भने यो लाइट रे के हुन्छ यहाँबाट माथितिर जान्छ, यसरी जान्छ है. तर मिडियमको यो सेकेन्ड मिडियममा लाइटको भेलोसिटी कम हुँदाखेरि के हुन्छ यो तलतिर जान्छ. सिम्पल छ, भेलोसिटी कम भयो तलतिर बेन्ड हुन्छ, भेलोसिटी धेरै भए माथितिर बेन्ड हुन्छ. लेट्स से रिफ्र्याक्सन अफ लाइट बुझ्यो कि बुझेनौ त, र कजेस अफ रिफ्र्याक्सन पनि बुझ्यो है. ओके, अब यो कजेस अफ रिफ्र्याक्सन पढ्दै गर्दाखेरि हामीले के भन्यौं भने इन सम मिडियम light has more velocity, in some medium light has less velocity. Okay, so when comparing two medium, when you compare velocity of light in two medium, then the medium in which light has more velocity or higher velocity is known as rarer medium. Will you remember the term rarer medium? Okay, the medium in which light has more velocity is known as rarer medium, and the medium in which light have less velocity is known as denser medium. Okay, so see, I have compared here some mediums like water to glass. When light travels from water to glass, you can see in water velocity of light is 2.27 into 10 to the power 8 meter per second, whereas when light travels through glass, its velocity would be 2 into 10 to the power 8 meter per second. So among these two medium, which one has more velocity? In water, light has more velocity in water and less velocity in glass. So water is rarer medium and glass is denser medium. Okay, now if you compare air to water, when light travels from air to water, if you compare between air to water, what you can find, in air velocity of light is 3 into 10 to the power 8 meter per second, and in water it is 2.27 into 10 to the power 8 meter per second. Okay, so by comparing these two medium, you can say air is rarer medium whereas water is denser medium. Okay, so when light travels from air to water, air is rarer medium and water is denser medium. Now by comparing these two examples, you can see that water was rarer medium in first example and it is denser medium in second example. Okay, so if you are asked to give an example of rarer medium or denser medium, you cannot say that water is rarer medium. You cannot give an example like that. Okay, when you need to give example, you must give example of both rarer and denser medium, because it is only comparative term. Okay, If you take water alone, then you cannot tell whether water is rarer medium or denser medium. If you take air alone, then also you cannot say whether air is rarer medium or denser medium. Okay, because it depends on with what you are comparing. Okay, it is just like asking like whether a particular person is tall or short. Like I can ask you, is elephant tall or short? Is elephant tall or short? Can you answer that question? No. As of it, you cannot answer that question. Okay, whether an elephant is tall or short, you cannot answer that question. Okay, but because if you compare the elephant to a tiger, then elephant is tall. Yes, but if you compare an elephant to a giraffe, then definitely elephant is short. Okay, so to answer whether elephant is tall or short, you need another reference. Okay, just like that. To answer whether a medium is rarer or denser, you need another reference. Okay, now here look at the note. Types of medium. Based on the speed of light in different medium are of two types: denser medium and rarer medium. And the medium in which velocity of light is comparatively lesser is called denser medium, and the medium in which velocity of light is comparatively higher is called rarer medium. And these are the two examples. Okay, understood? Okay, now this one we have already discussed. Yes, when light travels from rarer to denser medium, velocity of light decreases, so it bends downward, isn't it? And here when light travels from denser medium to rarer medium, velocity of light increases, so it moves upward. Or that to say, when light travels from rarer to denser medium, velocity decreases, and along with velocity the angle will also decreases. This is known as angle of refraction. Okay, this is known as angle of incidence. Yes, so in this case, when light travels from denser to rarer medium, velocity increases, and along with velocity the angle of refraction also increases. Okay, now come to laws of refraction. Yes, just like reflection of light, refraction also has laws. Okay, there are two statements. The first statement is the same as law of reflection. See, the incident ray normal to the point of incidence and the refracted ray lie on the same plane. In case of law of reflection, here it should be reflected ray. Yes, otherwise everything is same. Okay, that means if you keep a paper to trace this incident ray, then in the same paper you can trace refracted ray and normal as well. Okay, the second number, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of medium. That means here you can see this angle is angle of incidence and this angle is angle of refraction. Okay, these angles are not proportional, but if you take sine value of this angle, sine value, you know that, yes, like you have studied in trigonometry, sine 30, sine 40, sine 10, sine 0, just like that. Okay, if you take sine value of this angle and sine value of this angle, then the ratio is always constant. It's quite complicated. Yes, just remember this one formula or structure. You can state this on your own. See, the ratio of, this is ratio, yes, the ratio of sine of angle of incidence, I means angle of incidence, sine of angle of incidence to sine of angle of refraction is constant. Okay, and that constant is known as refractive index and indicated by mu. Okay, that constant term is known as refractive index and it is indicated by mu. Now this refractive index indicates to what extent does light bend. Okay, like in this case, if the refractive index is less, then you can say the light bends only this much. If it has little bit more refractive index, it will bend like this. Even more refractive index, bend like this. Even more, like this. If it has very high refractive index, it might bend something like this. Okay, so the refractive index tells you the extent of bending of light. Yes, higher the refractive index, more the bending will be. And this second number point, it was discovered by Wilbrad Snell in 1621 AD. Okay, that's why this is also known as Snell's law. Okay, so from Snell's law, these three conclusions can be drawn. These are the inferences drawn from Snell's law. Okay, first one, when light ray travels from rarer to denser medium, it bends toward normal. Yes, when light ray travels from rarer to denser medium, it bends toward normal, and we have discussed it already. Yes, it is because of decrease in speed of light or velocity of light. Due to that, angle of refraction would be decreased as well. Okay, and the second law, when light travels from denser medium to rarer medium, it bends away from normal. See, it bends away from normal. That is the only point difference. Here toward the normal, here away from normal. Okay, that means angle of incidence, this is angle of incidence and this is angle of refraction. Yes, so when velocity of light increases, angle of refraction also increases to the same proportion. Okay, angle of refraction also increases to the same proportion. Okay, and the third one, when light ray travels perpendicularly, whether it travels from rarer to denser or denser to rarer doesn't matter. If light ray travels perpendicularly, then it does not bend. It keeps on moving in its straight path. Okay, a refraction does not occur. Got it? Any confusion up here? Okay, see once again, recall what you have studied today. This is new topic to you. Okay, okay, first of all, you studied about refraction. Yes, what is refraction? Refraction is the process of bending of light. Bending of light. When does it occur? It occurs when light travels from one medium to another medium, or one transparent medium to another transparent medium. Okay, what is the cause of refraction? The cause of refraction is change of velocity of light when it travels from one medium to another medium. Yes, and what are the types of medium? The types of medium are denser medium and rarer medium. Yes, when the velocity of light, okay, the medium in which velocity of light is more is called rarer medium. The medium in which velocity of light is less is called denser medium. Okay, and then you studied about the laws of refraction of light. Okay, and the first law of refraction says that incident ray normal to the point of incidence and refracted ray, they all lie on same plane. And the second law says the ratio of sine of angle of incidence to sine of angle of refraction is always constant for a given pair, and the constant term is known as refractive index and is indicated by mu. Okay, and since this term was discovered by Wilbrad Snell in 1621 AD, the second law of refraction is also known as Snell's law. Okay, if you are asked to state Snell's law, then you can write this second point. All. Okay, and the inferences of Snell's law are: when light travels from rarer medium to denser medium, it bends toward normal. And number B, when light travels from denser medium to rarer medium, it bends away from normal. And number C, when light is incident perpendicularly, refraction does not occur. Okay, this much is for today's class. Okay, we'll continue in our next class. So I'm going to wrap up for today's class at this conclusion. Thank you very much.